This video I will show you how you can make a circular loop from just a simple wire, and that's what I have here. The wire is not connected to any batteries, so there is no current flowing. But if I want to make a circular loop, just fold it and there you go. I just create it. If I keep it like this, and assuming that this is roughly a circle, I will have a current flowing in a circular pattern here. Now this is just one loop, okay? I just made one loop. If you want, you can make another one, and now you have two loops, and you can keep making more and more. If you want to have more turns, more loops, just keep repeating the same process. Now I'm gonna show you how to find the direction of the magnetic field. So if this is, so let's say I make this, and you know what, just to make my life easier, I'm just gonna draw it. So the circle that I just did, I'm going to pretend that this is my circular loop of wire to make my life a little bit easier. And let's say that there is a current that's flowing this way. That's the conventional current flowing this way. I know that the right hand rule that I'm going to use with the circular loop of wire, I'm gonna place my fingers in the direction of the conventional current, and my thumb will show me the direction of B at the center. So the current goes this way and my thumb goes up. This means that the magnetic field goes out of the board. So at this point, the magnetic field points in this way. If I make the current to go the opposite direction, same process. My fingers of my right hand are curling in the direction of the current. My thumb now goes into the board. So that means that the magnetic field here goes into the board. This is the magnetic field created by this current. Now, if the expression that I give you in on the slides, and how to use to find the magnitude of B, it is important to understand that equation is valid only along this line. So let me make my loop. So if I make a loop, the equation that I gave you for the magnitude of the magnetic field is valid only at the center and anywhere on this axis perpendicular to this plane. So the equation that I gave you is valid only here, on the center and along this way. And this is the z-axis. In that expression, this is the z-axis, the line that goes through the center of the loop and is perpendicular to the loop. That is the z-axis, and that's where that expression is valid. Now, that expression is valid if you have a single circular loop. So what are you gonna do if you have two of them? We know that the superposition principle is valid for magnetic fields, and you will take that expression and multiply it by 2. If you end up having 3 loops, just take that expression and multiply it by 3.